Thank you so much, Kim. Very happy to be here. This is my second or third event that I've done with you, and I'm happy to talk about this topic. I know this, and I will explain it. Because if you look at the title, it kind of like devise cops is a team sport. It's DevSecOps. So I'm going to go back and explain. And I had somebody message me earlier, and I appreciate that. It's like, I don't know what it means, but I'm sure it's going to be good. I love talking about this topic. So I am, I have a very unique role in that I get to act as kind of an internal consultant in my corporation, as well as being a CISO for, not just, Carolina Complete Health, as Kim indicated in my bio, but also all of our subsidiaries, as we call healthcare enterprises. And so I get to kind of play virtual CISO again within this very large company. It's a lot of fun. And so as many other large companies are kind of going to a cloud first environment, it really impacts the way we manage our systems, the way we manage the development of applications, and the way that we kind of use the life cycle of how systems happen. Because in cloud, things are spinning up and spinning down all the time. It's very, very dynamic. It's not like it was 20 years ago, or even 15 years ago, or 10 years ago, where there's a big data center and someone goes and literally unboxes a piece of equipment, sets it in, plugs it on, sets it, plugs it in, turns it on, installs the operating system on it, configures it, and then makes it available to put applications. In the cloud, things can be spun up and spun down like in a matter of seconds, which are all of that all of the manual process that I had just described. And so when we talk about DevSecOps, let me kind of back down to DevOps. And DevOps is the automation of the process that I just described, where we install a system, we apply an application to the system, and we push it into a production environment. And that automation, which was developed by, the Facebooks and the Googles, 15 years ago, as they're constantly updating their software, became the model by which everyone kind of goes to today. It's kind of built off of something that was happened, 20 or 25 years ago, of agile development processes. So agile Scrum, agile XP, there's different types, about half a dozen different types of agile. And what that is kind of, instead of the traditional waterfall style of development, where you say, okay, I'm going to build this application, collect all the requirements, and then I'm going to build it, and then a year later it'll be released. What agile, Scrum, for instance, will do is say, okay, we're going to have these 2-week sprints where I'm going to put some features, and I'm going to do 2 weeks, and I'm going to release something, and we're going to test it. And then I'm going to do these other features for 2 weeks, and I'm going to test it. And that way, if you kind of, within 2 months, you realize something's wrong, it's very easy to change it, as opposed to like waiting till the end of a year later and then going back and fixing things. So this concept of an agile or XP, agile style development automated is what DevOps is. And so instead of humans, writing some code, testing that, pushing it out, getting tested, coming back and doing some more, it's all the automation of verifying that the code works, it's not going to break anything, and then it gets automatically pushed into production after it's tested and it's validated. And so I wanted to kind of explain that a little bit before I kind of get into it, to when we talk about DevOps, the security of DevOps in an automated fashion within this pipeline is called DevSecOps. So just want to make sure all that is clear, that we talk about. So how did we get here is my first kind of piece of this. And I don't have a lot of slides. You're just going to be looking at me doing a lot of talking mostly. But I want to be as explanatory as possible. And like Kim said, if you have any questions, feel free to put them in the chat. Caitlin will transition them over to my chat here, and I may see it, and I may answer them if I'm not on a roll or something like that. So we talked about evolution of SDLC, which is software development lifecycle, to CICD pipeline. CICD is continuous integration, continuous deployment. And what it looks like is this. I added this specifically, to kind of explain it. So when we talked about a development lifecycle, the old model was like design, build, and run. And in the cloud, we kind of talk about, we go from design, build, run to integrate, orchestrate, and automate. But when we talk about the continuous integration, continuous deployment in the middle here, this is what the pipeline, and we refer to as a CI/CD pipeline. And that is, there's a planning phase, there's a coding phase, there's a building phase, which is combining these components. Because you're going to have, shared libraries, you're going to have APIs, you're going to have different modules. The applications today are much more complex than they were 20 years ago, where we just design, build it, and run it. And then we have a testing phase. Interestingly, there is testing in the coding phase, and there's testing in the building phase and the integration phase. And then there's like a full testing phase where we talk about standard unit testing and system testing, which is making sure that the piece that I just developed is working as advertised, and then system testing that the whole thing is working as it's supposed to, and that unit didn't break anything that was in there. And then we have the release part. And so once it's all together and it's been tested, it gets released into a development or staging environment. And then there's a cycle, which is very important in DevSecOps, which is the deployment phase. And this is where, when it gets pushed in, some of these are pushed up on a daily basis, where all of the, there are multiple teams that are working on different modules in this code, and it gets, put into this, it's going through testing, and it gets into this release kind of bucket that's all queued up. And then the release phase is like, once you've met these certain gates, and you can get very complicated into like the trust of certain teams that are usually the quality is better than others, and you want more testing on some that aren't, or the fact that, certain modules go up, then the release happens, and it kind of like, you open the gate and it gets pushed up into production, and now it's live. And that's the deployment, actually. And then we get into deployment, the deployment of it. And then the operations, which is the ongoing maintenance of it. And so when we talk about challenges in cloud computing, and I'm going to get into that a little bit later, is that because some of these deployments are things, these applications are spinning stuff and spinning up and spinning down, and we call it like temporary workloads. So remember that server I said that, 20 years ago, someone would literally unbox and stand up and plug in and turn on and install. There's some of this code is actually developing that infrastructure. We call it infrastructure as code. And so when I'm going to like push a module, it's like, all right, I'm going to launch a couple of containers that are little, virtual computers, they have operating systems on them, and sometimes they don't, and I'm going to install the software, and it's going to run a program, and then it's going to just shut down and do, because I only need it for the 30 seconds to run this process, or 2 minutes or whatever. And this, again, this continuous deployment, make part of the dynamic nature of it. But the thing about these temporary workloads is, you may be getting an image that is used, that you copy the image for the operating system from some place as a mutable source. And there might be vulnerabilities that come up over time, and we haven't updated that base image yet. And so we kind of refer to that as drift. And the security world is like, okay, well, we haven't, the code is pulling this and updating this all the time, but we haven't like patched, or a new patch came out for a vulnerability from 2 weeks ago that hasn't been patched. And so we need to be monitoring that in the operations phase for when that happens, to then go back to the root source and say, okay, we need to either update the immutable source that was the image of which you're going to pull, or I might need to change the configuration in the infrastructure as code. So these are things that are kind of like unique about the cloud. So that's it. Now I'll get to number 2. I have an hour-long talk, but it'll go quickly. Trust me. The whole purpose of my talk is like, this is a team sport. And so because we have cloud teams, we have development teams, we have people who manage the secrets to those applications, we have people who manage the data, we have the people who manage the CI/CD pipeline as well. It becomes a lot of overlapping roles and responsibilities as we're moving through this pipeline here. There might be different teams that get involved. The number 3, the expansion of third-party infrastructures. When we talk about cloud, and I have the time to be able to kind of go explain this, is the cloud is not just one thing, and it could be many things. It could be one of, 4 things, but really 3. There is infrastructure as a service, and that's what Microsoft and AWS and Google here in the US are selling to like big companies, to say, all right, we have these infrastructures. You're going to then, create your virtual servers and your virtual networks and your virtual workflows and all these things on it. And there's a shared responsibility where the underlying networking and the underlying systems of which your stuff is on is the responsibility of the cloud provider, where you're responsible for the operating system that you install and load on there, and then the applications and access and everything all the way up, and the networking and how that is. And so there's that. Then you have infrastructures, then you have platform as a service, and that might be something like, an Oracle database as a service. And so that application layer may be managed by the platform as a service company, and then you just have the data that comes in and out, and may have some authentication, or you may be sharing that. And then that shared service, you kind of look at the line of who's responsible for once, that kind of goes a little bit over to the infrastructure and the owner of the service provider. And then you have software as a service. And, Salesforce is like the perfect example of that. Any business application like Workday, anything like that. These are just applications that the application, the platform, and the infrastructure is all managed by this cloud provider or the service that owns it. And then you're just really responsible for the data. And you may be pulling data from your organization to feed into it, like in Salesforce, or putting data in. You may be bringing your own credentials, like with a single sign-on from your own organization, so you may be bringing some pieces to it, but the rest of it is really under the responsibility. So I wanted to explain that because these different platforms and resources have different shared service models, and you as an organization may have even different teams that are working with these different organizations. So again, you see how it kind of gets more complicated, that we need to have these swim lanes and know who's really doing what. Number 5 is merging of the pipelines. And so now that because I have it still here on the screen, that this is what a pipeline is, a plan, code, build, test, release, deploy, and operations. And as I said before, testing is in every phase of the pipeline. I was working with one of my friends who's a professor, and he had a master's class, a capstone class, and their project was DevSecOps. And what I kind of helped them identify as they worked through the class throughout the semester was giving me things and reporting stuff to me, is like in the coding, like I said, the coding, building, testing, release, deployment, operations phase, there is testing and security testing in every single stage of this. It's just a continuous thing. And then, like I said, number 6 is there are new teams involved. Let me do a quick look at the chat here, because I already got some questions, which is great. If I don't get to it, I promise I'll circle back and get to it later. How do you differentiate between DevOps, DevSecOps, and secure DevOps? I think it's all well, the first two is DevOps is just an IT thing. It's not necessarily including the security aspect of it. It is, I develop code and I push it out. DevSecOps is the automation of the security mechanism that secures that. DevOps does include security if you have security within your DevOps pipeline, but the DevSecOps is actually where now I'm including, alerting coming from this that gets and which is automation really. And so if I see something in a testing phase, it gets automated to hopefully remediation as code. There's governance as code, which is going to be managing. So, hey, if something doesn't meet a certain threshold, that, then it won't be released. And so the automation of the security function of it is the DevSecOps. And then secure DevOps, I think, is just the same thing. I couldn't tell you a differentiation of that. Let's see, Derek, hearing's perspective on this, because I don't get to be in the DevOps and DevSecOps world very much. Yeah, but that's why I wanted to explain it, because it occurs to me that not many people understand how they all fit together. And how to ensure constant security requirements delivered with teams of varying security knowledge and limited pure security engineers. Yeah, I mean, it's all about technology supports the process. There are technology controls that can help support this, but having the governance, which defines what needs to be done, and you can automate that governance to say, well, I'm not letting you go live if your static code scanner has any high or critical vulnerabilities. I won't let you go to the release phase to even be deployed. And so you have to provide education to them on what is required of it, include that as part of the process, have manager buy-in to support it when they want to do an exception. And then just, it just takes time. It's not something overnight you have some set of tools or set of governance push out. It's an evolution, and different cultures kind of take to it better than others. Okay. All right. I have my little window here. I keep moving back and forth because I'm in my, I will actually narrow. Okay, there we go. I had like the gallery view of myself and other things, and I kept moving it because my words are on left and right of the screen because I don't know why I did that. Okay, so what I'm going to talk about I'm going to go over the security, the Cloud Security Alliance, which is a great organization. Everyone should join. Circle is their interface, and join if you have a local group of in your city of Cloud Security Alliance. I invite you to join that. I am, of course, on the board of the Charlotte chapter of the Cloud Security Alliance. We meet every Thursday at a great distillery right by my house, and so I enjoy that. But they've been around for over 12 years, and they are like a great source of cloud security knowledge. They are international. They have events all over the world, and I work very closely with them and speak at all their conferences. They came up with the 6 pillars of DevSecOps, and so collective responsibility, collaboration, integration, pragmatic implementation, bridging compliance and development, automation, and measure, monitor, report, and action. And so these are the pillars. And of course, I'm going to, as every slide thing will do, I'm going to go through each of them. But once I kind of get through like what our challenge and our goal is. So Racy is the, and I kind of say at the end, I don't like Racy, but in big companies, everyone uses a Racy model. So Racy is defining within a team who is R, responsible, A, accountable, C, what's C mean? C is something, and I is just informed. If anyone knows what the C is, put it in the chat. Sorry about that. But you're pretty much defining who is responsible for different pieces of it. And so what I don't like, and that's great because you should say, well, you're responsible, but you're actually accountable and blah, 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 blah. And you're just informed because you're not involved and you're just like, we'll communicate to you. And so, but the thing I don't like about it is while it defines the ownership, it doesn't really measure how well the team works together. And so a lot of people can like rely on, particularly in a big company, and this is why I don't really like using it too much, is that you realize like, oh, well, I'm the A, so, I'm sorry, I'm the I, I'm just informed. But you may like have a lot of knowledge and be able to fix it, but then it's just an excuse not to do anything about it. Consulted, thank you so much. Yes, consulted. So you may be consulted, but you have a lot of authority. Like I'm consulted a lot. I would be the C in a lot of these things, but I have a lot of authority over it just because I'm kind of play this internal consultant, subject matter expert. And so, but if I say it's like, well, that's not my problem, I'm just consulted, then that doesn't really fly very well. So when getting a group together, and this is something that it kind of dealt with because when we talk about a cloud organization, and when we talk about DevSecOps, it's really, we're talking about the cloud and cloud development or cloud implementation of platforms. And the cloud team probably did not exist in the organization 5 years ago. And it was made up of people that are refugees from the application architects or the network team or the server team or the data team or the engineering team or something. And they are like, oh, well, we'll be the cloud people now, because 10 years ago, there weren't cloud people. And so, and those people kind of came with their own, leverage, for lack of a better word, or authority or respect. And so with the pragmatic way, even though there's a Racy model that defines who's supposed to be doing what, including consulted, what it really boils down to is who has the authority and who has the responsibility, who takes the responsibility and has the clout to be able to get things done or get things moving or make decisions. And it might not be the team you think it is. And so we have so there might be the application architects that dictate everything of how the application developers work, but then many of them become cloud architects, and it's the cloud architecture team that does it. And there might be a CICD team that manages the pipeline, but they may have no authority whatsoever because they're all new people who came from outside who don't know the organization and how the politics work. I cannot emphasize how important the community, the politics, not for a bad word, but the way that the culture of the organization is and how the different groups interact plays into how successful it's going to be. And that is not anything that can be measured repeatable because it'll be different for every organization. Okay, so getting to pillar 1, collective responsibility. As I said before, there are more teams that are involved now. we have the developers, we have the the application architects, we have the cloud architects, we have the cloud security people, we have the security people themselves, we have the vulnerability management team who may have a piece in this because they may be running the tools to look for vulnerabilities. We may have a bug bar, which would be the development leaders who are prioritizing what to get fixed. There's a whole bunch of people. And so this pipeline may be shared by different teams, and there may be different teams at different stages of the pipeline, and there may be parallel pipelines. As we are developing a large application or a large implementation of some platform, there may be like 6 or 7 different pipelines going with different teams. Some of them are going across the different pipelines at certain levels of it. And so we are going to be having a lot of people that are involved with it. And so I talk about, like, you can read here, the specialists are different among these different areas. And then, there are new responsibilities because of this infrastructure of code concept and the governance as code concept. And so, for instance, I know in my organization, we have dozens of development teams. Some of them are very mature and some of them are less mature. They're doing small applications. So the more mature ones are doing this infrastructure as code, which is, as I described before, within the application, I'm defining the platform of which is going to spin up and I'm going to, take a container, a Docker container is going to spin up, Kubernetes is going to launch it. It's going to pull this Linux image that goes on there. It's going to install this particular application of this code. This code is going to go load on it. It's going to connect to this network and it's going to run this thing. And all of that's kind of all automatic and never touched by human hands, and that infrastructure code may be developed by the developers themselves, and they can test it themselves and validate it. Other teams that are maybe less mature may get that code from the infrastructure team in the cloud group, which may say, I'm not letting you touch that. I'm going to tell you what to do. And so you're going to call a function that will then do the infrastructure as code piece. You're not going to touch that. It all depends. And then when we talk about governance as code, there might be things in the pipeline that say, as I described before, okay, if the process of transitioning from, my code repository, in GitHub or GitLab into like my dev environment to be released before it gets pushed up into operation, I'm not going to let that move happen if the vulnerability scanner came back and there were critical vulnerabilities or something like that. So it's governance as code. There might be other things of certain versioning or certain other things that, the libraries had not been updated or something like that from a patching standpoint that the governance as code can complete. Again, the automation of something that we would have done manually even 10 years ago or 20 years ago. The second pillar is collaboration integration. And like I said, the cloud is a big application. And so it is all about collaboration with all of these different teams. So we talk about teams have different tasks. Now we know what CICD means. The security needs to be integrated and tested continuously. And this collaboration with the security team may be defining certain requirements of the security that, for instance, and here's one that happens all the time, is that, there might be the corporation may have a requirement that any server or any endpoint, whether it's a Windows or a Linux system, needs to have an EDR, whatever EDR stands for, like antivirus, enterprise detection response, something detection response. I don't know the acronym. But anyway, it's what, it's what CrowdStrike is, or MDATP, or, Sentinel-1, or any of these different tools they're on the endpoint. And so it may require that it's on that endpoint. But if this is a temporary workload, that's a container that's very lightweight, that's only going to be up for 45 seconds to launch an app, launch something, connect to an API, and then spin down, then I may not want, security may choose to say, I'm not going to require an EDR on that server, as if it were a persistent server. Like if you had a VMware instance in the cloud, we had these servers that were up and running and they were just virtualized servers, but they're not moving, they're not going up and down, they're just there, always performing their function. Yes, I would want an EDR on that from a protection standpoint. But if I'm just dealing with temporary workloads within containers, then I would want like a posture management tool, which is be something that would be just looking at, when it spins up, when it spins down, and make sure that everything is correct. And if it's not, then through governance as code, I can just wipe it out and relaunch it because it's all automatic anyway. And so these are the things that security may be part of from a governance standpoint, not just the vulnerability team, not just the credential team, who are setting the standards for what credentials are used, or the data team that's setting the standards for encryption or how data moves, et cetera, et cetera. So collaboration and integrating this and automation integration is certainly an important thing. So we talk about pragmatic implementation. So there's so many different point solutions, and I think I told the story too early, about the EDR and things to do. So I talk about the tools that each of these phases in the pipeline, and I probably should have like the pipeline just like as a ghost little table that's over every one of these slides, so you kind of think about, you have it there as a reference. But developers will use tools for code management. And so we talk about, and I'm doing a keynote in a couple months on just what the cloud security stack looks like, and so essentially you have, threat modeling, which is kind of the act of taking design and looking at all of the different ways that there may be threat vectors into it, and the different levels that these threat vectors could have, from a user level to an admin level to a service account level, et cetera. And then when the developers develop code, there are tools, these static code analysis tools, that are like, after they're done, they do static code analysis to make sure the code is not corrupt in any way, like just from error standpoint, but also they don't do they haven't included any securities in it, like cross-site scripting, SQL injection, all the things in the OWASP top 10 of web security that we've had for definitely 20 years, if not over 20 years, which are all the same ones, ironically. It's not like we gotten any better. And so these static code tools will look at the code and make sure those are not in there. Great. And then, the cloud team, I talk about there's automated testing that the vulnerability management team of security may do. Once it gets released into a development environment, they may run a tool to just check that infrastructure is good, a vulnerability scanning tool, for instance, or an application vulnerability scanning tool that may crawl through the application, make sure all the directories are appropriately, controlled, from permission standpoint. That, again, another check for cross-site scripting or SQL injection, or that there's privileges and cookies are being released, or there's not, anything that is in the URL, in URL rewriting or things like that could be a vulnerability. And then once it gets put into production and sitting there and it's running, there are these posture management tools that I kind of referenced before. And these are examples of them. Famous ones are like Orca, Wiz, Daz, Prisma, Sysdig, Bionic. There's a whole bunch of them. And what they do is they kind of monitor these containers and see like what's accessing it, what data is kind of going, the flow of data. Some of them can map the whole architecture of that. This particular application is connected with this API, which is connected to this database, which is connected to this identity platform, which sends data to this web server, et cetera, et cetera. And so these things kind of give a good handle. And so the cloud team through operations may be watching, the cloud team may implement this, and then security operation may be monitoring this. And then there's governance tools that I kind of described before, and incident response tools. So if something goes wrong, there are tools that are cloud native to be able to do incident response. Some of them are like the posture management tools, but some of them are also native to whether you're in Azure or AWS or Google Cloud or GT, so that you may use. Now, we still have a long way to go with that. But again, these are more teams that need to be involved in this DevSecOps process that we're trying to automate to be able to automate the remediation more. And so the centralization, orchestration of all these views need to be there. And then when I talk about that, like who owns them, and who manages and maintains them. And so in a very big company like I'm in, it gets tough because there might be tools like the posture management tools that that may be used by almost everybody to see like, well, what's there and what state is it in. It might be used by security operations, might be used by incident response, may be used by the developers to make sure the infrastructure as code is working, might be used by the audit team to be able to get the report, all these different things. And so who's going to pay for it? You would think it's a security team, but it might be the cloud team, or it might be the CICD team. Again, your mileage may vary depending on what your organization does. If you are a company like mine that we're a healthcare payer, so we provide, Centene, if you never heard of it, is the largest public healthcare company. So we do manage Medicaid, Medicare, and Affordable Care Act in all 50 states. And so our job is to pay providers who are providing services to our beneficiaries, and they send us claims and we send them payments. But that's our core business. We make the applications that do that for medical management or claims processing, or all the analytics, or all the portals the doctors have to know the state of the patients and everything like that. We develop those applications internally. And so, our business is, working in healthcare, but we have subsidiaries who their business, that all they do is develop healthcare analytics applications. And so this company, one of my companies, they're an application development company. And so those developers are really have the most authority, because the company is a development company to make an application. Our developers may not have as much authority because they are making applications that support our business. So again, that's why I'm saying that depending on how you're structured and your culture or organization, some teams may have more or less influence. So in my subsidiary, it's the development team that owns all of these tools. And they don't even have a security team. We do the managed security service of monitoring it and responding if there's an issue, but they have it. But in my organization, it's handled by a different group. So there's never one right answer. Well, there is one right answer. It's the one that's right to your organization. Pillar 4. Bridging compliance and development. So historically, there used to be, and I remember, maybe I'm going back 30 years now, that, when we would develop an application, you'd be like, there was a whole library of documents. There's a need statements. There's a data dictionary. There is a application, there is a, requirements document. There is all these different documents. There was this library of like 15 or 20 different documents that need to be there, that before you even wrote a line of code, that, you would have to go through formally to do this. Everyone hated it. Nowadays, like, the code is the documentation. And people love that because we want to be much faster. But it makes it difficult when 20 years ago or 25 years ago, they say, well, can I see your application documentation? Here you go. You may have heard of the SBOM, the Software Bill of Materials, which has been a big thing, particularly as we talk about the supply chain of code and how did this code get in here and who wrote it and et cetera, et cetera. And let's just get a bill of materials. That is essentially what I'm talking about. And so that software bill of materials defines, like, what are all the modules, what the API is called, what are all these different things. And that becomes like the documentation, and nobody likes doing documentation. So it makes it much tougher. Then this coupled with, there's multiple stakeholders in the pipeline I've talked about, and then the politics, which I think I just ad nauseum talked about, and I actually said this. Oh, look, I I keep telegraphing what I'm going to talk about, but at least it's now written down. So if I was rambling too much, you can at least read what I said, because okay, now I have a question. John asks, detailed and answers a lot of questions about the origin and reasons to continue with security operations activities. Oh, great. Happy to help. So yeah, you got to watch everything. The thing I love about the cloud is nothing happens without being known. The cloud's a big application. Anything that happens is logged somewhere. Now, whole other discussion, whole other thing about cloud incident response. How the different cloud things log is a whole other discussion. Some do it better than others. Some logs are easier or harder to get. Some even change over time, but that's a whole other thing. But nothing happens without being known. And so that's what's great about it, is you have such visibility, and all the cloud security tools and these cloud posture management tools, you don't have to install anything. You just get some service accounts and you go to the cloud management platform, you go to the container management platform, you go to the identity management platform, and you just pull the information. You crowdsource it from already exists, because we're not adding anything. I don't need to install anything. I just need to pull from stuff that already knows, and I put it into a portal. And that's what's kind of great about it. It's a very easy implementation, and then you can be able to do things. And so that's when we talk about, to finalize this pillar of compliance, is, all of the data is there. It just needs to be in a format that's easy to grade to make sure you're compliant. And that becomes kind of the challenge with this. And then when we talk about the auditors, you may have it in a format that whatever the tool has, but you are doing it against, NIST 853 or something like that. And you want to be able to easily check the box. pillar 5. Oh, another question from Michael. Comment on the CMS requirements for our data migration integration from web apps. The reason why I'm pausing is like web apps are, are nowadays, I would say most web apps are backed by the cloud. And so this is kind of like how you get to it. And one of those different things in the architecture would be all the stuff I just described, and then you push it to a web server, the web server being the interface to it. And that web server is likely in the cloud. When we talk about, if you're asking the question, and maybe I don't understand it completely. If you're talking about moving data from development into production and, not having production data in development, which is kind of a standard thing, it's actually easier to manage that in the cloud because, what happens a lot over the years in governance, and I'm on the steering committee, is that, there's like, oh, well, we have a customer. And like in our case, it might be a state that is giving us, production data to use for testing. And we're like, well, we don't test with production data, but our customers who we have the contract with are requiring us to do that to test it. And they want access to a development environment. In the old days, it'd be very expensive to like go buy a bunch more servers to set up a pre-production environment with all the security controls and logging and security operations that a production giant has to monitor it. In the cloud, it's easy. You just spin up a whole new environment, pre-production, do the same thing. And instead of a dev, you may have pre-production. You may have 5 or 6 of them. You may have, development. You may have in user development. You have user acceptance testing. You may have pre-production. You may have staging. You may have different environments, and then they may have different security requirements, and they may look more or less like production depending on the needs for it. And so, but I think if the question goes to the provenance of the data to make sure that, it is encrypted no matter where it's supposed to be, if it's in an area that is not protected, then absolutely. And that can be part of the governance as code is, oh, this data can't get over here unless it's encrypted and the encryption module is being called to be able to do it. If that didn't answer the question, please ask it again. So pillar 5 automation, this is the core of DevSecOps. This is the core of DevOps. And this is the core of DevSecOps. The nirvana we want to get to is remediation as code. I have infrastructure as code. I have governance as code. I want to be able to get to. So what I would love to see is that my posture management tools would be able to say, hey, this particular container is not patched. There was a vulnerability that came out 2 weeks ago. It had not been updated. We need to patch this. And then that patches and, goes back to where in the code was this done, or where in the immutable resource that location it's being pulled from, and say, here is the patch that needs to be installed. And I write a script gets created to update that. Because the problem is when you're talking about vulnerability management in containers, you don't have like 100 vulnerabilities, you have 10,000 vulnerabilities because it keeps getting replicated. And so if you just patch it in the container, it's going to get refreshed and then it's going to be bad again. And that's where we talk about the drift and the configuration. And so, what I would love to see is like, okay, this patch needs to be done to these containers and there may be 5,000 of them. And so I needed to update these 4 sources. And then the code goes and says, all right, well, I'm just going to go patch those things. And then, ultimately does it automatically and then creates a ticket in whatever your system is, ServiceNow or whatever, saying, hey, I patched this, and oh, here's a button to back it out if there's a problem. That's what we want to get to. Because right now, what it is, hey, we need to patch this thing. I can automatically create a ticket to say, we need to patch these 3 sources. And then a human goes and patches them and then closes the ticket, and then it's fine. But, wouldn't it be great if, first step, it creates a ticket and it says, press this button, it will automatically patch them. And then press this button if you want to release them. And then if you feel more comfortable, like I said at the beginning, where it just goes and patches them and creates a ticket that it patched it. And or goes through the workflow of approval process for change management, blah, blah, blah. And then that kind of happens. What level and what stage do you ask for documentation in Agile DevSecOps? It really should be at every stage and like at the beginning. I mean, there should be a full design that should be created. What you'd be looking for might be this automation. I mean, this is where threat modeling tools come in handy because they do all that, because you already went through the design and you can just do this whole UML diagram that kind of shows the flow of everything. that defines where the data goes, which data is sensitive, lagging into this, compliance team of the data classification guidelines you're feeding into. Yeah, I'm sorry. The short answer is like at every level, but mostly at the beginning. And depending on what you have or what platforms you're using, you can get them from those platforms. Your like I said, a lot of the documentation is the code itself, so the code repositories may have some good sources of that. So automation, okay, code scanning, vulnerability scanning. Okay, I think I covered all this. Back to legacy operating most commonly. Yeah, so this is a very important point that comes up is when we get into cloud and we talk about infrastructure as code, and I talked about that container may have a flaw. Did it get there through infrastructure as code, or did it get there because the infrastructure team made this immutable source, this image that they use to pull it from? Because if it came from one, it may go to ServiceNow, which is what the infrastructure team uses. Or if it came from infrastructure as code and it's a code change, it may go to Jira, which a lot of development teams use. And so knowing which path it goes for the workflow is something that really we haven't got to that point yet. It's still a manual thing, but I would love to do automation of like knowing where it came from. And then we get to the final pillar, and then I will open it up for questions, or I will just keep talking. Measure, monitor, report, and action. So the I talked about like the broad environment. I talked about that we used to have big servers. We talked about short life cycles. There's more stages within the production, within the environment. And I talked about the different thing. Asset management becomes very critical. This is also big, like I said, very easy in the cloud because nothing gets spun up without being known and logged about it, unless you have some other, account that somebody's using, and like, phantom IT kind of thing. But if it's within the process, then everything is done. The centralized view is kind of an important part, because a lot of times these teams will be siloed for various reasons, but from the cloud perspective, we should be able to see everything. And that's where these posture management tools really come in handy. Monitoring is distributed because different tools, as I kind of talked about, the crowdsourcing capabilities. Most of these pieces are, the alerting and response. And so who gets alerted? I talked about if it's a bug that needs to be fixed, is it a patch that needs to be installed? Is it a vulnerability that needs to be remediated? Or is it an incident that needs to be responded to? And so those types of things, because when we talk about security operations, like, I may not choose to pull all of these logs out of the cloud and put it into my very expensive SIM tool that may be on premise or in another cloud, which also is expensive just to move that data. And so I may have to kind of change what I look for, or just do alerts and then have the data stay there and say, okay, if this trigger happens because of this scenario, then I'm going to send a thing to my SIM tool just saying, hey, you may want to look at this, come up here and look at the data, because I'm not going to send all the data to be able to do the correlation. Maybe a little manual. We still doing security operations among multiple cloud environments is something that we're still, the industry is still working on, because we still have legacy SIM tools that are in one place or another or on premise that, it's the cloud providers do not make it easy. There is a protocol to do this, and they do it, share data among them, but it is not consistent. It sometimes changes, and it's sometimes expensive. So that's where I talk about the most critical is alerting and the response to knowing something wrong, and who coordinates all of that, right? One of the things is that we really are developing. I used to make this joke. I talk to lots of technology companies and work with lots of startups, and occasionally I'll get the one that like has a so unique niche idea that I'm like, okay, I like the concept, but you're making me create a new organizational structure. They're like, what do you mean? Like, well, I have a team that does this and a team that does this and a team that does this. And you're saying you're giving me this single pane of glass that checks all of this stuff. I don't have that team. So you're asking me to, technology supports a process, not the other way around. However, in the cloud, you may have to develop a team, because we have this centralization because of all the things I've been talking about before. Something needs to kind of have this broad view of it. And it may be shared responsibility among the team, like a little fusion center, or it could be, you give somebody who has authority access to that. So the takeaways on this topic, and I feel like I've rambled the whole time, so please ask me questions if I was confusing or contradicting myself anywhere, is know the teams involved, including the business stakeholders, the third parties, and incident response. So I didn't really touch on third party aspect of it, not just a cloud provider, and not just like the cloud service provider, if it's, platform as code or software as a service, but you may have other pieces that you may be pulling from third-party databases. You may be using some federated identity from third-party source, or you may be that source for a third-party identity. You may be getting code from third parties that you'll be using. You may be integrating through APIs to other applications. Understanding that whole thing is very important, because it becomes a much bigger piece than just your own. Understand the responsibility matrix, which I talked about before. Who's paying for it, and really who's close to the business mission? Because as technology people, we think that we know everything and that we make all the decisions, but risk-based decisions are business decisions, and technical people don't make business decisions. And even whether or not to accept to patch something, because it's a big vulnerability, it might be during re-enrollment, open enrollment, in which case we don't want to touch anything during open enrollment because that's critical to our business. And that's a business decision. And while we as a technology and security people may say, we need to patch this, there's a likelihood this could happen, they're like, yeah, we can't afford to have a business impact at this time. So we elect to defer it. And as long as they understand the risk to it and they sign off on it, it's a business decision, and it's not my place to say. And so which group is closest to that business mission to understand that and make sure the business people are part of these decisions. Having central governance function that links these two together, the business and the technical, to be able to help in these risk-based decisions, including you may choose not to do something or to do something. But again, at the end of the day, it's a business decision. And there we go. I think I have 10 to 15 minutes, 10 minutes or so left to answer any of the questions. I appreciate the questions that already came up in the chat. I will go back and through to see if I missed anything. Again, thank the person who gave me the clue in that the C in Racy stands for consulted. There's so many acronyms, I forget them. And even among tools, it drives me crazy when I talk to vendors, because they say, Gartner calls us a DASI tool. I'm like, what's that? It's like, it does this. Like, okay, that I understand, but I don't understand this category. That's crazy. Let's see. I think I answered everything to date. So please, yeah, if you have any other questions. The other thing I would kind of say is that everything is going, everything's going to the cloud. when I get talked to, when people ask what's the thing you want to talk about? Yes, there's threat actors out there. Yes, there's ransomware everywhere. Yes, there are, new requirements for passwordless authentication coming. Yes, there are things for bill of materials and applications that are coming from regulations, but, we are fundamentally changing how we maintain an infrastructure, from having, my organization has 3 data centers in, West, Central, and East. And all of that is now kind of moving to the cloud. And the cloud is such a nebulous thing because it's used so much. It's, what is the cloud? And it's this magical thing, but it really is just, and it honestly, if you go back and look at the history, Amazon, was the first to kind of start opening it up to other people, because, they built this infrastructure that's very dynamic and could, spin up automatically and was self-serving. And I think the 3 tenets of cloud are like that: it's self-service, on demand, and elastic. And when Amazon was, people would buy stuff throughout the year, come the holidays, people would buy a lot more stuff, and they would have to expand their infrastructure, to support all of the thing that's going on in November, December of all the buying. And then, when it's over, it kind of would come back down, but they still had lingering infrastructure that was there to surge in case, for instance, before Amazon deal days, but maybe, I don't know, like President's Day sales or whatever, that elastic. So they said, we could probably sell this to somebody else. And this platform is to somebody else, and kind of lease out these platforms. They're just kind of sitting there waiting to be surged. And if we really need more, we can spin up some other ones because we have the hardware to do it. And that's kind of how the cloud started, is just it's somebody else's servers that are somewhere that are, again, on demand, self-service, and elastic, that you can, and elastic meaning by policy, so that if I say I'm going to spin up 3 servers, And if these servers get to 70% capacity, I'm going to spin up a third server. And so if all those get to 70%, I'm going to start a fourth server. And so these concepts of being able to make it elastic, or if it spins down to like, if my servers become less than 30, I'm going to drop one, et cetera, because you play by the drink. So yeah, the comment about cloud communities empowering, allowing faster innovation. Absolutely. I don't have to, it was, 20 years ago, it was 20 or maybe it's longer ago. 25 years ago, we had all these Unix distributions, and I loved Solaris was my favorite. Sun had Solaris, IBM had AIX, HP had HPUX, Silicon Graphics had IRIX. There was another one that I'm missing. And then Linux was kind of coming along as kind of this little lightweight thing, but those were all on proper proprietary hardware. And so HPUX only worked on HPU systems. I mean, Sun did come up with an x86 version that you could run on commodity hardware, but for Solaris, but generally these were like, you bought the hardware and the software together. And so by allowing Linux as a lightweight and BSD and OpenBSD and FreeBSD, that you were allowed to be able to have these things that were that could run on just commodity hardware, and then that allowed for this to happen. And so again, within my lifetime, it changed from being able to do that. And so the cloud again makes it more accessible, where I may not have been be able to afford an $80,000 Silicon Graphics IRIX box to be able to do some graphics, but I can now just go spin up a bunch of servers on Google to be able to do the same thing, and I only pay for the 2 days that I'm using it. I mean, this is great. And so it allows, like I said, a lot of innovation. When you spin up a container, how do you validate security infrastructure is in place? How do you verify container shutdown and all data is purged? Yeah. Oh, that's what the posture management does. Is it, so that's where the governance as code and posture management kind of does. So it's like, okay, I'm going to spin this up. There's certain requirements that are going to happen, that these configurations need to be done, that needs to be patched to this level. Only these software components are on it. Only this network connection is going to be connected. Only these ports are open. And if all of that is yes, then I launch it and I release it to the world or deploy it to the world. And if not, I just say, nope, I'm not letting you spin up, and let's try again. And we'll see if it happens. And when I talk about like spinning down and taking things down, you're right. It's kind of like a hard drive. We already heard the thing about when you delete a file on the hard drive, you're only deleting the access to where it is located. It's not like you're deleting the file unless you wipe it out and do a bunch of zeros across the actual places where it is. So the cloud is like that. It's like a very big hard drive, in that I'm just saying I'm deleting it. I'm like, okay, I'm releasing that service to another service, and I'm releasing. And because when we talk about cloud infrastructure, it is essentially, it's compute and it's storage and it's networking, compute, networking, and storage, I guess I'll say. And so, I'm going to say, I'm going to take, 4 processors and, 18 gig of storage, and I'm going to spin this thing up, and I'm going to install this image on it, which includes my operating system and my applications, everything. And I'm going to configure it in this way, and I'm going to give access to it by this account, and et cetera, et cetera. And then when I remove it, I just delete all of that, delete the access to all that. And I free up those resources to be used, but that exact, within Amazon or AWS or Amazon, AWS or Azure's infrastructure, those processors that are sitting in big systems that are in data centers around the world, then get used for something else when someone else says, oh, I need 2 processors and this and that, and then that just gets overwritten. So, and that's kind of part of that shared service model, is like that whole underlying infrastructure is not touched by anybody outside of that infrastructure. And it's something that they have custom applications that kind of take care of that and releasing and everything like that. And there might be things where like you have residency requirement for data that it can only be within a certain country or not in a certain country. Those kind of things may come into play, in which goes those governance, your rules kind of come into. But yeah, so we have never had an issue where there has been a cloud, infrastructure that like, oh, I spun this up, but there was some residual thing that somebody else found. Correct me if I'm wrong, but I read these security news every day, and that's like, years ago when I was a virtual CISO, and someone, when I was trying to convince him, like, you need to go to Office 365 for your email. It's really just Exchange hosted by it's, it's a platform as a service. Pretty much Microsoft will now take care of managing your Exchange. And then guess what? It's the fastest way to upgrade, because you're still on, Exchange 2008 or whatever. And it's the fastest way to upgrade is just move to Office 365 and let them keep it up to date. That's great. And he was like, I don't know. I don't trust it going to the cloud. I'm like, listen, managing an Exchange server is finicky and it goes down all the time. And I've been here for a week and it already went down once. I said, that is a much bigger business impact than what you think about worrying whether or not Microsoft is looking at your stuff or whether they care. So it's kind of doing that risk assessment of it, that they do a much better job of managing it because they have resources and automation decades old that are doing this than what you have and what resources you have, particularly if you're not a Fortune 100 company. So I think we're getting down to the end. I thank you very much for, here's my last slide. After my questions is me. There we go. Feel free to connect with me on LinkedIn. I also have a YouTube channel called Rick Cybersecurity Videos, where I have a bunch of videos where I talk about cybersecurity things. And I'm on the editorial panel, as Kim mentioned, my bio for the CIS critical security controls. And I have a series of videos on my YouTube channel about each of the 18 controls and what changed from version 7 to version 8 and why we got rid of things or why we added things and stuff like that. And so feel free, it's easy enough to find. As you heard Kim kind of say, I'm way overexposed. I talk about all these things. I'm everywhere. So reach out if you need anything. Feel free to connect with me on LinkedIn. Thank you very much for your attention in this, and have a great rest of the conference.